Welcome to yet another video in this series on how to become an architect. In this specific video, we'll be focusing on a very important topic on how you would want to organize your code. What are the best practices around it? What are our experiences around organizing code? When we talk about organizing code, it's at multiple levels, right? So we start with talking about which microservice or which component needs to go into which layer, which package, which class, which method. So there are multiple levels that decisions have to be made when we are talking about organizing code. And there are a number of principles and best practices that are around that. So the goal here is to have a conversation at a high level around some of the important aspects around these things. Koushik and Shiva, glad to have you here.
Thank you for having me.
So, as I was saying earlier, like whenever we talk about organizing code, there are multiple levels at which we think about organizing a code. I would want to build a piece of functionality. The first thing I would want to decide is which microservice or which component it needs to go into. And then we get into a specific component level and try and dig deeper into which layer, if we are using layers, which package, which class, which method. So, probably like what I was thinking about was to start from bottom up, kind of start from the low level, start from the variables, methods, class, and go further up the chain up to components, microservices. Kaushik, I mean, just probably let's start with a general overview of why you think organizing code is important, and yeah, what are the things that you take into consideration at a high level?
I think organizing code is a very important part of writing code. When you write code, you're not just looking to get it to work. You're also looking to have it be maintainable. I forget who it is that said anybody can write code that a machine can run, but it's only a skilled programmer who can write code that other human beings can understand, right?
Absolutely.
So I think a big part of writing code is to make sure that your colleagues or perhaps even your future self can look at that code and try and understand what's going on. It's the first thing. And also try and make the process of modifying that code simpler. So code never lives as something that's written in stone. It's constantly evolving, constantly changing. One of the things that's very different in the software engineering principle as opposed to something like a civil engineering principle. You build a bridge. The bridge is not going to constantly change and evolve over time, right? You can probably add attachments, remove attachments, but with software engineering we end up tearing down large structures, and it's like it's expected to be that way. So as a result, we every time we write code, we have to kind of be mindful of the fact that this code is going to be transformed, it's going to be evolved, it's going to be changed over time, and make that process, whoever is doing that job, make it easy for them to do it. So there are a bunch of principles that have been evolved over time in order to make that simple, and we call them best practices. We call them, we even bake it into the language and say for something like object oriented programming, that's one way of organizing code. So there are the various complex schools of thought. So it goes from something as simple as, hey, these two pieces of code belong together, put them together, to these whole sciences like object oriented programming and various other related concepts like that. So yeah, I think organizing code is super important.
Absolutely. I think the example you give there is absolutely something which is very important for software engineers to understand. Software evolves over a period of time. You probably maintain software for a huge amount of longer period of time, and during that period, your code is read more. So the time you spend to read code is much more than the time you spend to
Absolutely.
write code,
Yeah.
right?
Yeah.
So, Shiva.
Yeah, when we talk about building better software systems, right? We talk about at the high level architecture. Maybe we want to build a microservice, or we want to go for an event-driven architecture. So serverless. So at the high level, we can pick any architectural style, but ultimately, how you organize code, how you maintain the code quality, that matters the most because that's where the complexity lies in. At the high level, you can pick whatever the architectural style you have, but how you write the actual code? How do you organize it in such a way that over the time, as Koushik mentioned, it is going to evolve. And we spend significant amount of time reading code than writing new code. So it should be in a way that new developers or even you should be able to understand and enhance it. And again, there are lots of different ways of doing it. There is no one right way to do it because when you apply, how do you uh, organize code in a microservice? It could be very different from how do you organize code in a monolithic application. And yeah, depending on the application style and the complexity of your application also impact how do you want to organize the code. Yeah, there are lots of ways. I hope we can talk about them uh, in depth a little bit.
Absolutely, absolutely. But there is no one best practice which would apply to all situations and contexts.
Yeah.
Organizing code is like something which is specific to what you are doing. So it's like, so it's something which also changes with time, right? So if you looked at like when we started off, probably we were talking about packaging by layers, and today probably the best practice is to go package by feature. So even with time, some of these best practices kind of change. Cool. So when we talk about organizing things, like we have things at a low level and things at a high level. Like when we talk about things at a low level, we are talking about methods, classes, packages, layers. Probably we are talking about things which are specific to a particular component or a microservice. And in here, probably some of the important things that play a critical role are the basic fundamental principles of programming. I mean, like for me, like I kind of think of 4 principles of simple design as kind of the fundamental things which help me to organize things at a low level very well. And other than that, probably things, the style of programming itself, object-oriented programming, functional programming, these would also help us in organizing things at the low level. Koushik, do you want to start with an overview of what are the things you go about at a low level, right? Whenever we're talking about methods, classes, packages, layers, what are the things you would consider when you start off?
There isn't like a fixed list that I would look for. There are a few obvious ones, which is a repetition of code is like an immediate thing that screams out like, okay, this needs organization. We have the same piece of code that's put in multiple different places. You want to extract that out into a separate method or a separate class or a separate file, depending on the language you're using. Why is that? Again, it has probably very little material impact to the present, but again, we are talking about future changes. Like if that piece of code has to change, imagine if that were to be in multiple different places, then they have to go change all of them, right? That's the reason why we say duplication is bad, not because it affects us today. It will affect us tomorrow when we have to change the thing that is duplicated. So wherever you have such kind of duplication, the first immediate thing that comes to mind is extract it out, put it into a shared method or a shared class, and have this refer to that. Makes it easy to change later. The other thing that comes to mind is good practices depending on what kind of programming style you're using. So for object-oriented programming, there are a set of patterns that you follow. Like we follow a single responsibility principle for a certain object or methods in a class. We follow encapsulation principles to make sure that every class has a certain contract and it's not exposing more than it needs to, right? So what is it that the consumer needs? It's almost as if you treat each class as kind of like an API that someone external to the class is calling. Even if it's just you're writing that class, that doesn't matter. It's still an API. It's like, what should that consumer know? What needs to be protected? What needs to be private? What needs to be public, right? With functional programming, again, you have patterns around it. So for example, immutability is an important pattern. When you're doing functional programming, you want to make sure that the functions are pure functions. Again, what's the point? It doesn't affect us today. But if you have an external state and you're doing functional programming and your functions have a side effect, you move that function somewhere else, something is going to break because the external setting is not exactly what the function needs. So functional programming, we talk about pure functions, avoiding side effects, and so on. So depending on the type of programming style you have, You have different patterns that are pretty much well established as best practices. Those are some things that I would explore next, and from there it goes on. These are things that it's like, as I'm saying this, I'm realizing it's hard for me to kind of list down, okay, I'm going to check this, and this, because these are things that, all developers kind of acquire over time, over years of experience. So it's not like we go through this laundry list and then memorize it and then apply it. A lot of it comes from experience, but there's a lot of patterns that repeat. You just do them over and over again and kind of become second nature.
Absolutely. I think that's also a big challenge, right? Because if I go and actually look at coding standards for Java, there are about 200, 300 coding standards that you need to adhere to. And if you want to remember all of them, that's never going to happen. And that's where I think kind of abstracting them into common, simpler ways of remembering them is where I think the programming patterns and all that kind of stuff comes into picture.
When we think about organizing the code, what are the things that we consider take care of low-level design aspects, like how do we create classes, how do we organize into packages, or how do we put them into different methods? One way I do it is like when we are building something, a feature, I treat it as like we are building an API and somebody is going to consume it. And then there are parts like what they are interested in, and there are a lot of implementation details that they are not supposed to or doesn't care much. So when we start with TDD, right, this is a good thing. Like you act as a consumer of your own API, and you can go ahead and implement that feature, saying that, okay, this is my main API method, a public method. This is what it expects, and this is the implementation details doesn't have to be exposed, and I can implement all that functionality. And then it's not like in one go I get it right, where I know what methods to expose and what to hide and all that. Basically, I cook all my functionality and then slowly I refactor it. And if I feel, okay, I am putting multiple things into a single class, I kind of extract it and make it a package private class, and then provide all this refactoring, so that from the consumer point of view, they should look at it as a simple API. They make a call and they get the response. And internally, you can hide all this. Maybe it's a private method or a package level process, which nobody has to bother about. So that's the approach I follow, kind of iterate and refactor. And again, private methods, and then usual coding standards like okay. And one common thing that I frequently notice is, where do you put the validation? Do you put all over the place, checking everything in every method? But I kind of go with the approach of doing all the validation at the public method level, and after that I can assume that the application in a valid state, so that we don't have to repeat everywhere like in private methods and all that. Otherwise, it's gonna pollute in a lot of places doing the same or different sort of validations. So these are the things. As you already mentioned, there is no laundry list of, okay, put a check mark for all these 24 different things. You are good to go. There is no such thing. Like you build and then do continuous refactoring. Uh, this is how I would definitely approach.
Absolutely. Awesome. So like when we talk about low level design, one of the constant discussions like which has evolved over the last few years is this discussion around package by layer versus package by feature. Shiva, do you want to explain that?
Yeah, sure. So traditionally, when we are building monolithic applications, right, our application might contain multiple things. Let's take an example of, say, e-commerce application. There could be a catalog management, there could be order management, there could be inventory management. And when you are putting all of these things, traditionally, when we follow package by layer, you have controllers, you have services, you have repositories or DAOs, whatnot. And controller will talk to service talks to repositories and all this. It starts nice, but the thing is, over the time, your one service talks to one repository, and then sometimes based on some feature request, you might want to talk to another repository. And also, as the requirements evolve, you might want to use some other service also. So over the time, without even realizing, it gets tangled, talking one service, talking to multiple things, and it becomes like a many-to-many calls. It's gonna get so tangled after a while. If you want to refactor something, you will break a lot of things. So that's when it makes sense to go into this package by feature. And then if still there is a lot of code, then package by layer inside each feature. So in the same approach, right now, instead of having high-level controller services and EAOs, you will have orders and then catalog and inventory. And inside that, you put whatever is belongs to order management in that orders package. And one good approach with that package by feature is you can hide details of, okay, if you are building it as a API, only your service needs to be exposed. Ideally, any request to get any information about orders should not talk to your repository directly. So you can make it as a package private so that nobody will try to call it. So that way you can protect some internal parts of your application logic. And again, the tricky part with Java is if code in a particular feature grows a lot more and more, and if you try to put it into a different package, again, you need to make it as a public, then everyone can access it. So I think in some languages like Kotlin or somewhere, you can make it as a module internal. I don't know how it is done with Node.js or JavaScript code, but this is a challenge that I'm seeing. Like if you put all of them in a single package, you can make it a package private. But if the code grows and you want to move it to a package, you need to make it public. That again defeats the whole purpose. I don't have a definitive solution for it. Maybe module system or they might help, but I'm not sure how it.
Kaushik?
Uh,
I feel like module system could help if we build it the right way. There is this sense of what you want to export from a set of packages. Um, Packages have always been a very loose way of organizing code in Java because it doesn't matter where you are. You can have one package with the same name here, another package with that same name somewhere else, and it treats it as all part of one big thing, which may not necessarily be true. So having modules helps. I haven't had a lot of experience with modules lately. I used to work with that initially, but that's one way to achieve encapsulation. It's very similar to how things work in Node.js as well. You kind of hinted at that. Even in Node.js, you tend to have essentially each file becomes a module, a JavaScript file becomes a module, and then you export from that module. Whatever is not exported is just not visible outside, right? So that's one way to handle it. But then again, it's basically what we're talking about here is how do you control access to certain things while allowing access to certain things. We're talking about the API, right? Again, designing things as an API, not because someone else is using it, but because you want to have that kind of agreement between two classes or two entities in the same code base. Yeah.
Absolutely. Cool. I think there was one aspect we were talking about in there about controlling access. I think the other aspect probably is also like packaging by feature would help you to refactor to a separate component much more easier. Like one of the things that we saw with the microservices architecture was like we would want to evolve over a period of time. It's not like I decide when I start off that this is the microservice this particular feature would go into, and it would end up there for the long term. It's basically that, okay, over a period of time, you learn something, and based on that, you would want to evolve. And probably if we are going to take that route, package by feature might be much easier thing to refactor to a separate microservice than packaging by layer. Um,
Actually,
another, go ahead, Shiva.
Actually, recently we did the very same experiment. Like we had a monolithic application. We want to move to a microservice-based approach. Initially, it is not at package by feature style. It is in a package by layer style. When we thought about okay, extracting one specific domain logic into a separate microservice, we realized it is tangled so much. We ended up touching almost every single class in every single layer. So instead of going in a big bang approach, we first move towards this packaging by feature style. So we, in the same monolithic application, we moved all the functionality into this one particular package. And then we extracted that one particular package altogether into a separate microservice. It's a two-step process, but then we realized why it is such a good process. Maybe you don't have to go all the way into microservice architecture. Maybe for your particular application, monolithic architecture is good enough, but still following this package by feature will enable you in one day if you have to extract it as a separate service. That is very easy compared to going with package by layer.
Right.
It's also
And
easy to remove
another,
features, right? You
it
want
is
to get rid of a
definitely,
feature, just delete one package rather than
yes,
figuring out where it's used. So that's
exactly. So once we moved this into a package by feature, what we did first, we just extracted that particular package into a separate module, and then we run it. And all we did is delete that package from the monolithic application. As simple as that. So, and also one another interesting thing we noticed is uh, here we can move into a different packages in a modular monolithic structure. But the thing is, we need to enforce in certain way that these packages are not coupled in a, multiple ways. So one approach is you can make it as a different module so that then it will be explicit. Like you are depending on so and so module, that means you will be explicitly know that you are not having bidirectional dependencies. Whereas in a simple package by feature, it's all leave up to your discipline. Like you are not calling this from there and from that into this one. So that helps moving into a separate module. But for some reason, if you want to stick with that in a single module structure with a feature package by feature, one tool that really helped us is ArcUnit. So there is a library where you can specify, okay, this package should not depend on any other package. Things like that. Okay, your repositories doesn't should not call services. So that kind of rules you can enforce using ArcUnit. That's also a wonderful tool to use.
Absolutely, absolutely. So, like, I think what we were referring to there is how to keep things loosely coupled even within a specific application, right? Even though like a specific set of features that belong to a specific microservice, how do I keep each of those features as loosely coupled as possible so that we can break it out and kind of move it if there is a need in the future? That's awesome. Like I think we were talking about some of the principles related to like organizing code at the low level, right? One of the things that Koushik touched upon a lot was single responsibility principle. The other ones are like kind of encapsulation, having loose coupling, high cohesion, the typical ones, right? These are like object oriented principles or functional programming principles. So that's another aspect that we would need to really consider when we are talking about low level design. Shiva, do you want to like any important aspects there you want to touch upon from the principles perspective?
Yeah, these are the two major things that comes to my mind when we talk about low-level design, right? Hide the internal implementation detail and go for a single responsibility principle. And as I already mentioned, you don't get it right in the first time. I'm a big fan of copy paste and then refactor. Don't try to abstract without even knowing what you are repeating. So usually I write for first use case, and if there is a similar use case, I shamelessly copy paste. And when a third time similar requirement comes, I refactor. So I don't try to abstract aggressively because I had a very bad experience of going aggressively and abstracting things. I most likely even end up having multiple flags. Okay, if this is the flow, you do things in a different way. So to avoid that, you will have to have some kind of a context and a maturity of what you are abstracting. And in my experience, you will get it most likely in a better way the third time you are copy pasting something. So yeah, I follow that approach.
Awesome. Now that you bring that up, Shiva, I think one approach that we used to do a lot a few years back, maybe a decade back, maybe even further than that, was draw a lot of UML diagrams ahead of time, right? So have perfect UML diagrams, like have perfect low-level design before you would even start writing code. where where do we stand with respect to that today, Koushik?
I think UML diagrams are still useful when you're trying to model a very complex business use case, and you have classes do a lot of interactions with other, like objects do a lot of interactions with objects of other classes. I think there is a lot of web applications that we built today, which I know somebody I read used to call we just skinning the database, right? Web apps. A lot of web apps we write are just web skins for the database. We're just doing CRUD in a very fancy way, right? So for those kind of things, maybe not that simple, but even so, a certain level of complexity, a lot of these classes have we kind of know what the classes do, right? You have a controller, you kind of know what the controller does. There is a very specific set of business services perhaps that it calls. Go to a business service, well, there is a very specific set of data services that it calls, and kind of like all the roles are kind of defined. And Spring has this great concept of a stereotype, right? A stereotype kind of allows you to typecast a class. Okay, this is what it does, this is all the interactions there, and that's it, right? You wouldn't want to write a UML diagram for that. But when you have a lot of business services and there's a lot of complex business logic where you have all these different classes interacting with each other, passing different things, there is a certain order in which calls need to be made and all those things. UML diagrams can be a lifesaver because it's very hard for you to kind of look at the code and try and understand what's going on. A UML diagram allows you to see those relationships. So I would say don't just blindly go with UML diagrams. At the same time, don't say UML diagram is a waste. It has its use. You just have to apply it at the right time.
Absolutely. And another thing I observe is generally we used to actually have probably tool drawn diagrams earlier, but one approach which we switched over to in the last few years is kind of the approach of drawing things by hand. It does not have to be a well-drawn picture first up. Probably something like a prototype, a simple hand-drawn drawing might be a good starting point for discussion. And maybe as it gets finalized, you'd want to put more effort towards making it more of a standard, wherever there is a little bit of complexity involved. Is that something you see as well, Koushik?
Yeah, no, that makes a lot of sense. For most of the cases where, what was I thinking of? Usually, for most of the cases where there is business complexity, right? You start out with a lot of planning. There's a lot of there are projects that I've been involved in the past where it is like that. So you're trying to create software which for a domain which has a lot of business rules and a lot of regulations and all that. You tend to see that in something like finance and insurance and all that, right? Even you talk to the business stakeholders, even they don't have a full picture, right? So they have this, maybe you're trying to convert something legacy into a modern stack, or maybe they're doing pen and paper work and you're trying to convert into the modern stack, although that use case is less these days. There isn't one picture which tells you what's going on, right? So a lot of times you as an architect or a senior engineer would be talking to those people, talking to the product, trying to understand what would be a good representation of what's happening right now, irrespective of how you design it as a system, right? What's going on right now? What does the domain require? And what is the best way to kind of put that on paper? It would be a good UML, like it could be hand drawn, something like that, some kind of like an intermediate representation of that complexity, so that forms a bridge between the domain experts and the software engineers and the teams who are working on it. So it is a little old school, I agree, but it is still very useful when you want to model those complex scenarios.
Absolutely. Shiva?
Yeah, almost 10, 15 years back, I saw one tool where you can draw these diagrams and then generate a Java project with all those classes and then dependencies. But I don't see any of such things in the recent years. And also,
Those
when
never
it comes
worked
to
for me. I don't know if you had a chance to try that out. Like those always used to fail for the oddest of reasons. Like something didn't work, or the code that it would generate would be garbage. So it would just create some kind of a starting point, and then we would work on it. I don't know if that was your experience, Shiva.
Yeah, that's how those are useful, right? Once you generate it, it's going to change. Definitely, it's not going to be in the same way. And I don't see any of that approach in the recent years where starting a project with the UML diagrams and all those things. But again, I see when we talk about UML diagrams usefulness, I see sequence diagrams, especially, they are really useful, especially when you are trying to understand some complex processes, how it works. Maybe there is a lot of complex interactions between multiple components or services. They are really helpful. But I'm not really a big fan of drawing class level diagrams because they are the ones that changes very often. Every day you extend and you refactor, and most likely you generate or create those class diagrams, and most likely in a couple of days they are obsolete. They are not going to reflect the way the code base is. So, and also these days we have tools where you just right click on a package and then show as UML, and it is going to show it. So there is no need to generate them and put it in somewhere so that somebody assumes okay, this is how the structure is, and most likely 99% there is a chance that that's not how the code is right now. So I like sequence diagrams to understand the flow. The class diagrams, I don't like them much. Uh, but again, these days, if it is a product and people are coming in, new people join, and they want to understand, this is where they are really helpful. But yeah, but somehow I see people are not big fan of UML diagrams anymore. Again, it depends on how you have used in what way.
Yeah, I think we are. I think rather than rigid design, kind of, we are moving towards the evolutionary design, and you don't want to like draw diagrams around things which change very very often. Uh, like it's usually a waste of effort anyway. So probably like both of you were suggesting, it's like the flow, like that's something which might remain constant over a period of time, and that's where probably having a high level documentation will be really useful for somebody to get started, but probably the low level details are not something you'd want to document extensively, at least. Awesome. Just referring back, going a step back to the earlier discussion on packaging by feature, I think one thing which I wanted to touch upon there was the evolution of orthogonal architectures, or the hexagonal architectures as it is called. So how is it related to package by feature? Shiva?
Yeah, when we talk about hexagonal architecture or clean architecture, to my understanding, right, there are multiple slight variations of this hexagonal onion architecture, clean architecture. When I look at all of them, what they are trying to do is, again, my understanding is to isolate the core domain logic from the external interactive things. Like you have your core domain business logic, and how it is how someone is going to use them through a REST API or through a messaging system, how they are going to invoke that business logic. So the idea is to isolate that core domain and then build it in a such a way that it always put the system in a integrated manner, integrated data integration, integrity. So the idea is, if your core logic depends on any external service, put an indirection there. Don't directly hard inject. Okay, you are talking to a database. Don't actually implement the logic in such a way that your core domain is talking to the database. Put an indirection, maybe an interface, and then inject that dependency from the outside. So this way, when again coming back to the how we organize the code, you have your core domain package where you put all your business logic, and then you have adapters, inbound adapters or outbound adapters, things like that, where how you get the request through HTTP API, how you talk to the external dependencies, outbound adapters like a database, a messaging system. So you invert those dependencies. So usually in hexagonal architecture, right, you have your application or domain package, which contains core use cases and then their implementations. And they depend on some set of interfaces, both inbound, outbound adapters. And you have inbound package, how you receive your request, web request or messaging adapters, things like that. And then outbound adapters, how do you persist the data to a database, or how do you send messages to some other Kafka or whatnot. So this is how I see code organization when we go with the hexagonal architecture.
Awesome. Koushik, do you have anything to add there?
No, I think Shiva covered it very well. That's that's one way to look at it. I have seen people kind of try to move away from hexagonal architecture these days. Some people say that that's too old now. We don't want to do that. But still, I think it has its place, and that influences how you. One of the benefits of hexagonal architecture is also isolating the code that doesn't change often from the code that could potentially change often. I think that's a huge value, which you still want to do, whether you do hexagonal or spherical or whatever else. You want to have that separation, right? Have the core separate out. So it's a new way of looking at organizing. It's not just packaged by feature or packaged by layer. This is packaged by importance, or kind of like packaged by likelihood of change, or grouping by likelihood of change. I think there's value in that as well.
Actually, one thing I noticed is we have all these various types of patterns, right? Lean architecture, hexagonal, onion, variety of things. When people try to adopt one of these styles, they try to go all the way up to 100%. Okay, we are following 100% clean architecture style, where there are middle grounds. You don't have to follow all the things in a certain type of architectural approach. There are few things that are applicable. There are few things that you can violate based on some other advantages. One of the thing I keep noticing is when people talk about clean architecture or hexagonal architecture, they talk about framework independence. Okay, our specific code is completely independent of any framework. So we don't use any framework specific annotations, and our core domain model is completely independent of any framework. We can reuse with any other. This is all nice in theory, but how do you? Okay, there are a lot of things frameworks provides, like transaction management, caching support, and things like that. Security. There are a lot of things that frameworks provide these kind of features, where you want to remove all those framework dependencies, and you want to achieve framework independence. There is a cost to it. Nothing comes for free, right? You are removing all those nice framework provided features. So you have to implement them in some other way. So that's a cost. You need to understand that. What are you trying to build? Okay, what is the chance of you rewriting this application into a different framework? So you need to evaluate the pros and cons before going with, okay, I want to go with the hexagonal or clean architecture. I want my code to completely independent of frameworks. I don't go into that mode. Like, you need to think about what you are going to pay. Framework independence doesn't simply come for free. You have to pay extra cost of hooking up those things. In my opinion, pick whatever suits good, and pick some things like one another common pattern I see is you have web request object, and then you have one use case command object, and then you have a response object, and most likely they are all exact copy of the same data structures, and just they go by rule. No, I want to have a complete independent layers. That's a stupid thing. Like, you just have the same class and you're copy pasting whole lot of things, and it's a performance cost, and there is no real benefit out of it. So what I'm trying to say is, don't just go by the okay, somebody wise said that in a context, without understanding that context, blindly applying all these patterns and thinking of framework independence and layer independence. That's going to cost you a lot. You need to evaluate really those advantages you are getting, or you are just blindly following some patterns. So I just pick few things. Okay, in clean architectures, few things are nice, and in hexagonal architecture, few things are nice. I try to apply what is applicable for my particular case and ignore rest of them. I'm not clean code certified module. I'm not trying to build that. I'm trying to build a particular feature for my customer.
There are always challenges with being perfect, right? One of the when Spring annotations were initially introduced, one of the arguments against using Spring annotations was that your class code would get polluted with Spring annotations. Like earlier, you had thousands of lines with thousands of lines of XML where you declare all the dependencies and stuff. That's okay, but polluting your class with annotations, even though they eliminate all the thousands of lines of configuration that is needed, that's not good, because it's polluting your class and you'll not be able to use another framework with this specific class. So
Yeah, also
I think
I have another interesting discussion a while ago. Somebody was saying, if I put all this JPA annotation on my object, at entity, at table, and all those things, that's a framework coupling. So I don't want to do it. Rather, I would go create orm.xml and put all that configuration. That is absolutely fine, but don't put annotations on the class itself. Then I asked, dude, what do you think at the runtime? Does it have independent, or is it a proxy? I don't know. So this is the kind of thing. Without understanding what is happening at the runtime, they simply follow. Oh, I don't want annotations. I am fine to write 250 lines of XML, which is same thing at the runtime. Yeah.
Absolutely. Yeah, things. I mean, I think as we were talking last few sessions, right, a lot of times context is the thing which dictates. It's not like every rule is applicable everywhere, and it's about, like, maybe there are places where having everything in XML makes sense. I have not seen such a place, but you need to understand that, and like before you apply a rule, you need to understand the context for which that specific rule was designed. Absolutely.
And again, this is the one common notion I'm seeing. See, most of the times we learn from great people and their literature, like Clean Code from Robert C. Martin, and then many things from Martin Fowler and all that, right? They said many things in a context. Given so and so scenario, this is the right thing to do. They always say with a context associated to the problem. But what happens is most of the people leave about that context and take it as a thumb rule. Okay, you should follow all this pattern, and that's where what do you call it? Cargo cult programming, like without having the context. Okay, follow this 100% of the times, all the times. So this is where we need to. Yes, they are great people. They said great things in a context, but that doesn't mean that you ignore and just blindly follow it. Evaluate. Does it really apply to your problem? Or does it make sense in your context? Then use it. Otherwise, just don't follow all the patterns.
Absolutely. I think from, like, we have been talking about low level organizing our code until now. Let's probably move over a little higher, like to the high level things. How do you organize into microservices, components, and things like that? We did have a few discussions around that in the last few sessions as well, right? So we were talking about microservices architectures, reactive architectures, event-driven architectures. Koushik, any specific things you would want to highlight with respect to how you choose your specific architecture style at a high level, and also like any specific best practices that you want to highlight in that specific context?
Again, this is a very difficult question to answer, because how you choose your architecture has a lot of different factors. There isn't like a list of, or probably a flow diagram of, if this, then go here, otherwise go there. I wish there was one, but there isn't. I think a lot of it comes down to basically a lot of non-functional requirements. The core of architecture is to address non-functional requirements, right? You can, if you just look at the functional requirements, there are 100 different ways to structure your code to get the result that you want your application to give. A lot of these nuances, A versus B versus C dilemmas come from non-functional requirements. And often what ends up happening is these non-functional requirements are contradictory to one another. Okay, so you will have often product managers come and say, well, I want it to be performant, but at the same time, I want it to do all these other things. It's like, yeah, you have to pick one or the other, right? So what ends up happening is people usually have to make a lot of trade-offs and a lot of compromises. So I think that's the biggest challenge, and that would be the first place to start with this, choosing an architecture. It's like, what are the non-functional requirements you have, and try and come up with a value system for it. Yes, you want it to be performant, you want it to be accurate, you want it to be a great experience for the user, and you want it to do these 10 other things. how much of these do you value? What is the value of performance opposed to accuracy? What is the value of accuracy as opposed to customer delight? So having a good value system, first of all, identifying these non-functional requirements, having a good value system for those non-functional requirements. Oftentimes nobody would have thought about this. Like if you're a consultant or an engineer talking to the product, they would know. It's like, can I not get everything? Like software is supposed to be magic, right? Or you might have a savvy product manager or product person that's there as well. So kind of having them think what is the most important and kind of building that value system, and then architecting for that is the way to go about it. If you
Absolutely.
want to architect around um, I want availability to be the key and I don't care about accuracy all the time, then you go, well, okay, maybe do we want to look at distributed systems? If they go, well, no, I don't care about availability, but when it shows up, I want it to be accurate. There's a lot of regulations and all that stuff. You wouldn't think of going to a distributed system because you will have to deal with eventual consistency the minute you go to distributed. So again, I would approach there. Notice that all the things that I'm talking about is not technology, it's not frameworks, it's not what jazzy new buzzword comes up. It is about the needs, the non-functional requirement, the business needs. So that's how I would start choosing an architecture.
Absolutely. So if you're, for example, building a DNS, the most important part for it is high availability. You don't want the DNS server to go down.
Yes.
However, if you're building a database, durability is the most important part. You are okay with probably it not being available sometimes, but you don't want to lose any transactional data which happens. So durability might be absolutely based on the kind of
you
system.
see that in those experiences, you kind of expect that as well. So if you make a DNS change, it doesn't reflect immediately. Why? Because it is meant to be designed for eventual consistency. It values high availability at the cost of reflecting changes. So again, it's basically the value system. You have trade-offs. It makes it, those choices make itself once you have a good value system.
Absolutely. Siva?
Yeah, I think Koushik already talked about how do you approach your at the high level design, right? There are things that you need to take as a priority, and there are things you might have to compromise on few things. And when we talk about implementation side of it, how do you design your application considering those priorities? In my experience, it is like if team understand what's going on in the code, it is much easier to make it more performant. Whereas if it is hard to reason about, it is much harder to make it more performant. So I always first lean towards organize your code in such a way that it is easy to understand. So in that way, you can profile it, and then you can see the hotspot, and you can optimize some bits of it. Though it is not very readable, you can make small portions of it to make it more performant. But by and large, I give more priority to make it easy to understand and reason about. So in that way, right, there are multiple ways. The first level is like organizing the code in a feature by feature approach. Where suppose you are a developer and you joined a new team, a new project, and how do you scan through the code and try to make sense of it? So if there are a bunch of controllers and services and all, you don't know what kind of a features your system is providing. Whereas with the feature package by feature, you can look at the high level package structure and say, you can have a glance and then see, okay, this system is trying to do these kind of sub components. And then based on the need and then flow, you can dig deeper into it. And also there are different schools of thought. One pattern that I recently followed is usually what we do, we have a say customer controller with multiple handler methods, and then you have a service, customer service, which have various operations on customer information, things like that. And recently I come across one approach where each endpoint has a dedicated, okay, get all customers controller, which has a get all customers service, no, not service, get all customers command. So each one is doing a specific, handling a specific request and processing it. no cross referencing of any other thing. At a first glance, it looks like is it not overkill, like having a separate class for each endpoint and each method? But over the time, it becomes really easy. Like you have some problem with any endpoint, you know exactly what three classes you have to check. You don't have to worry about the 10,000 other classes. So though it looks like not we used to use this approach, I see there is a great usability and maintainability point of view. It looks very simple. You have isolated each use case, and then you handle it in a very specific way. Uh, in that approach, the downside is there is a little bit of duplication of code, slightly, but from the readability point of view, it really helpful in the long run. That's one way of doing things. And a different way is the usual pattern. You have a controller and you have service and things like that. But what I would strongly recommend is not let anybody directly talk to your repositories. Every call to your specific package need to go through the service only. Because the moment you expose your repository, that's where the mess starts. Everyone poke around the information which is supposed to be a private to your service. So at least I would make service as a public, and then maybe there are business functionality and the database interactions, things like that, that I will try to make it as a private. Uh, that's a decent approach that seems working fine.
Cool. I think one important aspect you were touching about there is having a standard kind of a structure, right? So if
Hmm.
I know this is, once I have thoughts in my mind about specific functionality, I should be able to locate where that is implemented uh,
Hmm.
very quickly. I think that's
Yeah.
one of the important goals of how we organize things.
Hmm.
I think that's where the Maven standard structure really helps,
Hmm.
right? Any project I go to, I know, okay, it will have a source main Java, it will have a source main resource. I want to find properties, it's where I'll go. So like, even though it might actually vary from project to project, like specific to Maven, probably it will not vary from project to project. But even like, there are situations where the structure you use might be different in each project. But as long as you have a standard structure in place that is followed in a specific project, that really
Hmm.
helps you in being able to maintain it easily over a period of time. And also, like, one other like aspect which we did not touch a lot upon was cross-cutting concerns and having common components across applications for a lot of these technical features, right? Authentication, authorization, a lot of these are common across like different uh, components that we build, different microservices that we build, and probably like building them as a separate component on their own might be really useful. Koushik, do you want to quickly touch upon that?
Yeah, cross-cutting concerns is usually a problem when you think about, we talked about package by feature, right? Usually when you say I want to take a piece of code and organize by feature, there's always going to be, pieces of code that you don't know what to do with, right? Does this go here? Does it go there? Um, so those are always tricky. You can probably draw a line and say, okay, I'm going to put it, I'm going to have some convention and put it over there. But there are some which are so widely spread across different such pillars that you really cannot split it, with a certain demarcation, right? Those kind of things usually tend to be cross-cutting concerns, what we refer to as cross-cutting concerns. The very common example of cross-cutting concerns are things which span the whole application. Authentication is a good example for it, right? More often you have some kind of an application which needs sign-in or some kind of an auth, and you have 100 APIs. All those 100 APIs need sign-in, authentication, authorization. So where do you put that thing? Do you put it as a package of its own? Do you have all these individual package by features and then have a package of its own? Do you separate out individual things which apply to each feature and make it available across the board? There are different ways to go about it. We take the example of Spring Boot. Spring Boot uses something called aspect-oriented programming, and kind of it takes that decision away from you. Spring Boot uses AOP. Well, Spring in general uses AOP for a whole lot of things, But basically, it uses an intelligent combination of aspect-oriented programming, the proxy pattern, to basically say you define it in one place. And at runtime, it is going to apply it to a bunch of different places. Like the cross-cutting concern is going to happen as long as you define what are the different pillars that the cross-cutting concern needs to be applied to. So that's a good way to structure cross-cutting concerns, but it is also a little risky because it is a little more complicated than you would imagine. Use the framework support, then yes, you get that benefit. But if you have to do that yourself, AOP can be a little tricky, can be error prone. There could be bugs that you have no idea what's happening. So most of the times, thanks to the frameworks, they have thought about these cross-cutting concerns like logging, authentication and authorization, all that stuff. They have framework support. So when there is framework support, that's a good way to structure this code. When you don't have framework support, we need to make sure that you don't over-engineer it. Sometimes a little bit of duplication is okay in my mind, rather than coming up with some elaborate scheme to completely separate out the cross-cutting concern. A little bit of duplication is okay. So there's a trade-off that you're gonna have to take.
Absolutely. So cross-cutting concerns, whenever we're talking about low level, code level, probably aspect-oriented programming. And when you have cross-cutting concerns at a high level, probably something like an API gateway or something of that kind.
Right.
The microservices
Right.
architecture might be a good place to go. Awesome. Shiva, any final thoughts on organizing code?
Actually, on the same topic, what Koushik described, really this cross-cutting concerns is really tricky. Like you have to compromise on one thing to achieve another. Taking the same Spring Boot example, let's say security, right? Usually on controllers, you can put some at pre-authorize and so on, so you have so on, so permission or something like that. In a way, you can see what role is required looking at that particular handler method right there. Whereas the downside is you have to put that annotation all over the places in the code base, different controllers, different methods, and all those things. Whereas other approach is you have a central security configuration where you can specify, okay, so and so package, it needs to have so and so role. You can centralize it on that. But every time when you have to figure out, can I call this method with my role? Is it allowed for so and so user? You have to go back to security configuration and figure out doing all the math and the order of that configuration. You need to do all that math. So it's always like compromise on readability versus centralized configuration, things like that. There is no one right answer here. You may need to pick one which suits for you and stick with it consistently instead of following different patterns in different places. Yeah,
Absolutely. Thanks, Shiva. Koushik?
Final thoughts. Organizing code is an art. They talk about code being an art. Organizing code is one of those things which is a bit of a non. It's not science. It's more of an art. A lot of it is usage driven. A lot of it is even organization driven. We heard of Conway's law. Basically, like your manager who has no idea about the code somehow structures your team, and that influences your architecture. Who would have thought, right? So there are a lot of external factors as well. At the end of the day, you have to look at trade-offs. There isn't one right answer. There isn't a checklist. We've covered that multiple times in this call. Look at trade-offs. Look at what someone else is doing in your organization. A lot of challenges that you face, maybe someone else who's been ahead of you has faced those and made those decisions. So it's always good to learn both from people in your company and outside, and learn that it's all about trade-offs. There's never one right answer. That would be my wrap-up note for the start.
Cool. Architecture is all about trade-offs. Thanks a lot, Koushik. Thanks a lot, Shiva. Glad to have you in here. And I hope to see you guys again very, very soon.
Thank you.
Thank you, Ranga.
I'm sure you had a great time watching this video. If you loved this video, do not forget to like, share, subscribe, and comment as well. Our goal at In 28 Minutes is to help you learn cloud, DevOps, and also programming. So go ahead, keep learning every day, and I'll see you again.